The original OE cam sensor design kept the small magnet in the middle of the unit exposed. Unfortunately, those magnets frequently break loose from the housing like this one did and falls into and destroys the synchronizer. The cam sensor is expensive enough, but replacing the synchronizer and the sensor is a much costlier repair. So why did the magnet break loose? There's a shutter wheel or interrupter that rotates around the magnet and activates and deactivates the sensor by blocking the magnetic field between the Hall effect sensor and the magnet. This on-off magnetic attraction ultimately causes the magnet to break loose from the original component. Our design advantage is easy to see. Our engineers use a 500-pound shear strength adhesive to secure the magnet in place. They also completely encapsulated the magnet in this plastic housing, forever eliminating any possibility of magnet loss failure. Think about it. This improvement over OE, engineered and manufactured right here in the USA, makes it sensible to replace the cam sensor before the original destroys the synchronizer. Remember, we've never had a failure. None. Zero. Problem solved. Another Wells advantage.
Hey, welcome to another Wells Tech live training event. We are so happy you are here. Today we're going to be talking more about hybrids. We got Jim Bates with us, and we're going to get in more detail, more safety, and how to use the equipment that you need and how to use it properly. So I'm really excited about it. We're going to get into it in just a second. But before that, of course, we're going to give away our Wells Tech t-shirt, yes. And even if you won a t-shirt before, you're welcome to win as many t-shirts as you like. As a matter of fact, we're gonna get some child-sized t-shirts so you can put these t-shirts on your kids too. Excellent. Okay, here's the question. Last time out, we talked about what category your meters needed to be rated at. Okay, what category does your meter need to be rated? That's the question. What category? Is it category 3? Is A? Category 4? Category double knot? Or category knot? Okay, there's your answers. Chat in your answer, and if you are the first one in with the correct answer, we will be sending you out a t-shirt tomorrow. All right. With that, I got Jim Bates right here. Come on in, Jim.
Hey,
all right. How you
Good
doing,
to
Jim?
see you. Hi, everybody, again.
Excellent, excellent. Welcome.
Thank you. Glad to be here.
We had a very good reception on your last broadcast. It was very good, and they want to know more.
Okay.
So we said, yes, we will bring Jim back. And here you are.
And I brought more.
All right, more.
So I thought one of the things that we could talk about, besides reviewing safety as we go, is some of the things that shops are finding themselves in different situations where, you know, you're not really advertising or expecting to work on a hybrid.
Right.
But one may come in with some specific issues that you need to know about. Based on what we talked about last time, you could address and repair. And of course, we'll talk about the safety as we go.
Yeah.
So let's talk a little bit about this. This is an air conditioning compressor from a Prius. And this one had to be replaced.
Okay.
The cool thing is now that they remanufacture these things, so
So the prices are much more palatable.
And working on an AC system is very much on a hybrid is very much like on a non-hybrid vehicle.
Yeah.
The only difference is that the air conditioning compressor is electric and it runs on the high voltage from the big battery in the back.
You're right.
And so because of that, we need to have oil in there that is not hygroscopic, and so it's a dry ester, basically. We do not use PAG oil in a AC system.
Is it the conductivity? Is that what we're talking about?
Right.
Okay.
Right. It can increase the conductivity of the oil, and since this thing is, of course, attached to the vehicle's frame,
you don't want that.
We don't want that. So this would actually cause, or has the capability of causing, a vehicle shutdown over time in the event that the oil becomes conductive and the PCM senses that rise in voltage in the system, and then it
Right.
would cause the vehicle to stop.
Well, that's very interesting.
stop
So if
running.
you put the wrong oil in, or the oil that's used on a normal car, regular car,
Right.
It could actually cause the electrical system to leak.
It could, and there's been a lot of discussion over that.
amazing.
But I think probably what you'll see related to that is something called ISO faults first. In other words, you'll see there's problems in the insulation, and that will
Okay.
trigger some mill lights, and it could cause the vehicle not to run,
Right.
and that could be the cause.
Wow.
Yep. So one of the things that we need to think about is when we get a remanufactured compressor, we want to make sure that the cables and everything are in good shape.
Okay.
When you and I first talked about this, you thought that we don't know what happens during shipping, or my thought
Exactly,
was at
yeah.
some point during the handling, what if somebody dropped this thing and caught it by
Or
here?
just picked it up like that,
Yeah.
you know?
So we want to make sure that that the insulation is okay as you and maybe your customer gets close to this thing at some point in time.
Right.
This is one of the reasons why we have things called an insulation tester.
Okay.
Not only to find out where the high voltage leaks are in the orange wires anywhere else on the car, but even when we're doing isolation diagnostics like this.
Okay.
So if you would like to hold that.
I would be glad.
And you don't need your gloves for this because,
right.
as you remember, this thing produces a high voltage but very, very low amperage, just a milliamp, one milliamp. So what we would simply do is first make a ground connection somewhere, and we'll just go right here. I guess you can see that okay from where you
Sure.
are. And then
We'll get a close-up of
yeah,
that.
and then we'll turn the meter on. And right now I'm turning it to the 1,000 volt range, so that when I connect up to these three individual wires, like so, and hit the test button, we can see that the number on top, that's the amount of voltage that this is generating. In this case, it's 1,000 volts.
So it's telling you it's able to handle 1,000 volts without leaking.
Right, but this is infinity. So we see there's no leakage on that cable.
Gotcha.
And we can
I'll do the test
do the
button
next
for you.
one. Go ahead. You're at 999 volts.
So we're good there,
1,000,
1,000.
good there.
Okay.
And good there too.
Okay, excellent.
All right. So now we know that we can handle, or the wires can handle the high voltage.
We know everything good is here. When we install this, we're not going to get a leak out of it.
That is correct.
Okay, that's
So
nice.
that's an idea of a.
That's
an
cool. That's
insulation
very
test.
easy to do too.
Right.
And
Another
safe.
thing that we find is sometimes that we get battery lights, for the high voltage battery encodes. And I brought a couple of modules along, and that's what they call these. These are modules. This is from a first generation Prius. That's like the old 2000 to 2002.
Yeah, the
And they were-
$5,000 battery ones.
Yeah, and these were plastic, and you can see the damage here. They crack and they leak and they
You can
swell
see
up
it's
after a
been
while.
leaking.
Yep,
Yeah.
and they can go bad. This is a second generation module, and you can see it's a little bit more robust. It's metal. These things are way better than the first generation.
Oh yeah.
In fact, when batteries are remanufactured these days, they will actually take a first generation battery and rebuild it with second generation
okay, gotcha.
modules.
So
But you
it
can
fits
see
in
the,
there, then?
Yeah, it fits
Okay.
in there.
Okay.
But the corrosion is still going to be an issue.
I see that.
There's like an alkaline electrolyte that they use in here. I think it's called potassium hydroxide, and it even sounds nasty, doesn't it?
Now, can you have a situation where, what did you call this?
A module.
A module, where one module, you have a whole rack of these modules, right? So where one module can get a bad connection?
You could, or it could actually fail from heat and that type of thing.
Okay.
And these things, of course, this is a first and a second generation, but in actual practice, there's two together, wired together, and it's called a block. And
Okay.
so in this case, these are 7.2 volt modules,
Yeah.
so we have a 14.4 volt block.
Ah.
And that's what your battery ECU is monitoring. So if it sees one of these blocks has got some problems, and maybe some low voltage, or it can't charge properly because of a bad connection, your scan tool could read that. It'd be a block voltage.
So it'll point you
issue.
to that block. Okay, so then it narrows it down to one of these two as a problem,
Right.
or both.
The other thing you notice that perhaps when you hook these together, there's air spaces in between the two. That's how they're cooled. The air comes in from the bottom and works its way up.
Oh, nice.
So if you have like pets running around the vehicle with fine hair, things like that, it'll plug these up after a while and the batteries will overheat and they will fail.
I'll be darned.
And for reasons like that, it is a good idea to understand how to hook your scan tool up, how to look at the battery's ECU data in custom data stream perhaps on your scan tool, or use a tool like this, and we talked about that last time, where you hook this up to your OBD2 connector and you drive around for a little while and let it analyze your battery while you're driving, and then you can come back to the shop and hook this up to your printer or just read the data and find out what is going on with that battery.
The printer is nice if you're going to hand the customer a substantial bill, that's for sure.
That's right.
Okay.
The other thing that we talked a little bit about was batteries, 12-volt batteries, perhaps needing replacement.
Yes.
As these vehicles get old, and some of them are quite old now, their 12-volt batteries are failing and they need to be replaced. So you could actually have a customer come in that says, well, it wouldn't start, I had to get a jump and, to get the vehicle going. What you need to understand is the 12-volt battery does not start the hybrid. The 12-volt battery runs the computers.
Okay.
So if you can't run your computers, the vehicle's not going to start. Sometimes the customer doesn't quite understand that progression, but he just knows that, hey, I think I need a 12-volt battery because my car wouldn't start. Now, is that the case? Do you need a 12-volt battery? Do you have battery cable issues where the battery could not be charged? Or is there a problem charging the 12-volt battery with something called the DC to DC converter? There's no alternator on the hybrid.
Right.
We use a DC to DC converter, which takes the high voltage battery's output and steps it down to the level that we need to run the car's electrical system and charge the battery, and it's somewhere
14
around
volts.
14 volts or so.
Yeah.
So what we can do then is use our regular voltmeter, and we can actually put the leads across the battery and see what we have at the battery at this time, what is our system voltage.
Okay.
And think about that. If you did that in your shop and open one of the doors on the vehicle, the voltage should drop, right? Right.
Or turn the headlights on.
Yeah, turn the headlights on. But then if you were to reach in and turn the vehicle on, even if the engine doesn't run on a hybrid, the vehicle is on, the voltage should go up, right? And if it doesn't, we know that we have a battery cable problem or a DC to DC converter problem. It's so easy to do on the vehicle, and I want to show you how to do that.
Interesting. Yes, let's do that. As a matter of fact, are you ready? You want to go check that out?
Let's do that now.
Okay, we got Mike Becker over here on a vehicle.
Okay.
You're going to go join him?
Yep, I am.
And I'm going to go take a nap.
All right.
And we're good. Right?
And I'm just going to grab my meter lead so I can do this.
Okay.
Get them all. Here we go.
Hey Jim,
Hey Mike, how's it going?
it's going good.
What have we got here?
This is our 2013 Ford Fusion Hybrid. This is the Energy model, so it's actually a plug-in also.
Very, very cool.
So what are we going to do today?
Well, you mentioned it's a plug-in, it's a hybrid, and so it's a lot of high-tech stuff. The good news is, for what we're going to do today, doesn't matter if it's high-tech with all these scary orange wires or not. We get to use our basic test equipment and do the sorts of things that we normally do. Like we were talking before, we have customers that are coming into the shops now with their hybrids because they had to jump to 12-volt battery to get it started, so they think they need a battery. And not so much this one, this is fairly new.
Right.
But we've got a lot of hybrids out there that have been there a long time, and they're getting really old, and 12-volt batteries have been acting up like any car's 12-volt battery and going to need to be replaced.
So if this thing has a dead battery and has to be jump started, is it going to act the same as a normal car will?
Yeah, pretty much. Well, one thing that a lot of our customers may or may not understand, and you probably do understand, that the 12-volt battery in the car doesn't start the engine.
Right.
Its job is to run computers, and so what's going to start the engine is the big battery in the back running the electric motors, or one of them, MG1, in the transmission that's going to crank the engine over.
Okay.
But to the car owner who needs a jump start, perhaps she just knows that it won't start, and somebody jumps her off, and now she's bringing it into the shop, thinks she needs a battery, and she might. But you do need to follow the diagnostic procedures that you would follow with any vehicle.
Right.
And kind of the way I do it, especially on a hybrid, By the way, when I do these diagnostics, I always like to do a test that leads me to what do I do next that I know is going to prove, my next step. Then what do I do next? In other words, what's my next step?
A good diagnostic process.
Yeah. And follow the procedures in your manual that you do now. But let me give you an example of what we're talking about. In this particular hybrid vehicle, the first thing we want to do is connect up, in this case, to the jump post.
Okay.
And we're going to look at the 12-volt SOC state of charge, see what it is, and then we're going to activate the charging system.
Okay.
And by starting the engine. And but what's going to be different here is that when we start this vehicle up, the engine may not run because it's a hybrid.
And there's no alternator on here that's belt driven or anything
Good
like that.
point. That's my next point. No alternator, no voltage regulator. Instead, we have a DC to DC converter that kind of does what the alternator did on a regular vehicle.
Sure.
So the DC to DC converter is a solid state component located in various different places on the vehicle. So you really do need to check your service manual on the vehicle that you're working on to find out where the DC to DC converter is. But we'll get to that.
Where is it on this car?
Well, it's in the back.
Oh, okay.
Sometimes they're, as long as you ask, sometimes they're in with the inverter-converter assembly under the hood.
Oh.
On some vehicles, like what comes to mind, Ford Escape, Mercury Mariner, Mazda Tribute, those types of SUVs, it's under the hood as a standalone unit.
Okay.
Many other vehicles will incorporate that into the battery pack area.
Okay.
So you got to find it to get to those steps. But first, we'll do the things that you normally do.
All right, so let's say this thing came in and the customer said they had to jump start it. What would be our first test?
Well, my first step is to go under the hood.
Okay.
Because I'm going to go to the jump post.
Sure.
I'm not going to go directly to the 12-volt battery for a hookup because it's in the trunk under a cover. So I have to take something off.
Could be buried by people's stuff back there too.
Absolutely. So those are things that we can get around if we simply just go under the hood first, go to the jump post, and I'm going to take and connect my voltmeter.
Now, when you say jump post, a customer can jump start the car with using that post right there too, just like a battery positive?
Yep. Just like on any vehicle that is equipped with a jump post.
Okay.
And then go to a ground place. This has a ground stud right there. And then we'll turn the voltmeter on, and we'll be reading the 12-volt SOC, or state of charge, which at the moment is 12.31.
Okay.
And I suspect that if the vehicle's battery is not in such good shape, we're going to see something that reflects much lower. If it gets below about maybe 7.5 volts, it's not enough to run the computers, and it's not going to start the vehicle.
Just like
and
on
you're
a
going to have
normal
to get
car.
out your jump pack and proceed. But what I want to do is make sure my hookup is good. So I'm going to ask you to open up the car door.
Sure. Okay, and by opening the car door, we're going to create a load in the system. We're going to
Some interior lights are going to turn on, and we should watch the voltage drop, which it's doing, as you would normally expect. So we know that the meter's behaving itself, and the hookup is good. So now what I'm going to have you do is start the vehicle.
Okay.
And I guess start is kind of a funny term with a hybrid, because the engine may not be running. But it's ready to drive.
Yep, that's what it
I
says,
can
ready to
hear
drive.
water pumps and things running. So right now we see the voltage jump up to 14.7, which is typical on the hybrids. And that means that the DC to DC converter is in fact working.
Okay.
So in this particular case, we could probably only assume at this point that the battery is not good. It would need to be replaced or something wrong with it. And you get out your normal battery test gear and test the battery, load it up, make sure that it's either good or bad, and proceed. The situation though that we have right now is that we have a jump post that I'm on, and the battery's in the back.
So there's a cable between there, right?
Quite a long one too.
Yeah.
So if I did not get what I expected here, I have to continue my testing by going to the back of the battery and hook up to the 12-volt battery to get SOC, and then have you open the door and start the vehicle and see if there's a change.
Kind of the same thing you would do on any battery that had a remote location, like older GMs, under the back seat and that kind of thing.
Right. But I hope everybody understands. Right now, if this was the case where the battery needed to be jumped, our diagnostics are done. All we have to do is test the battery itself under load and replace it. Okay. But let's just assume that that's not the case, and we did not get what we want here. Now we have to go back to the back where the 12-volt battery is and resume our testing.
Okay. So now I have heard that some cars have like a jump start feature or a button or something like that. Is that true? How does that work?
I've heard that too, but actually what it is some vehicles, some hybrids, like the first generation Ford SUVs, Mercedes-Benz comes to mind.
Okay.
If the big battery, the high voltage battery, loses charge over time,
Sure.
maybe it's sat too long, after a couple of weeks maybe the customer's on a cruise or vacation or something.
That sounds nice.
Nice. And they come back and they find that it won't, there's not enough energy there to run
Okay.
the electric motors. There is a way for the 12-volt battery through the DC to DC converter to boost the voltage and jumpstart the big battery.
Oh,
And some vehicles,
okay.
they can do that,
Okay.
but it's not the other way.
Okay.
So once your 12-volt battery loses sufficient charge, the vehicle's not going to run until we get another 12-volt battery connected to it,
Okay.
so we can run the computer.
I
That's the big
suppose
thing.
without the computers being turned on, it doesn't even know that it's low on charge.
I suppose not.
Okay.
Right. Okay, but before we do that, do you have
Yeah.
any questions?
Yeah, it looks like we have two people answered, Mario and Frank, and you both guessed right. It is a Category 3 for our meter for our test equipment. We want a Cat 3 meter. So if we can go ahead and put our email up on the screen there, send your address and your shirt size, and normally we only do the first person to get it, but we haven't had many answers back today, so Mark will send you guys both a shirt. So go ahead, send him an email, and we'll get shirts sent out to you guys as soon as we can. Shirt size and address in there. Okay.
All right, any other questions to address?
No, that's it. If you
All
guys
right.
do have any other questions or anything, feel free to comment in or send us an email, and we'll get back to them as soon as we can.
All
In
right.
the meantime, let's head to the back.
You bet.
All right. So we have the trunk open. We have
You have all the covers off.
covers off, and that's wow.
Isn't that something?
That
Look at
is.
this, like a roll cage for a battery. And this
they,
is a
they
very
really don't want any collision damage
No.
happening to that battery pack.
That is one strong structure. It goes all the way around the battery to protect it.
Okay.
And of course, this is the battery pack, and in there is in this case, a lithium-ion battery. The battery's ECU is in there, and the DC to DC converter is in there, and we'll talk a bit more about that later.
Okay.
But also, the 12-volt battery is back here, and this is where we're going to go to next. Especially if we did not get the results from our test up front. What if we have a bad cable between the battery
so
and the
say
jump
our,
post?
our voltage never went up on that battery up there. Let's see.
So what
This
we
is
have
what
to
we
do,
wanna test, right?
Yep, now we're going to go right to the battery,
Okay.
and really we're going to repeat the test. So,
Okay.
what I'd like you to do is, once again, let me get out of the way so you can see our meter.
Okay.
There's our battery's SOC,
Okay.
and then open the door, and we should see a drop.
Kind of put a load on the battery.
And we've done that, and then go
Okay.
ahead and turn the vehicle on.
All right.
And the battery voltage is starting to climb. It's
ready to drive.
14.5, 4, 5, 6 or so. And it's going to be a little bit lower back here than up front because we've been drawing from the battery, and you can expect that. But somewhere around 14.5, 14.7 is quite normal DC output, DC to DC converter output on these
That's just
batteries.
pretty much a normal charging system output, really.
Pretty much is. All right, so in the event that we still had a low reading here, you go ahead and, like I said before, get out your battery test equipment, load it up, and then make a determination that you're going to have to replace this battery. And in this case, you probably would. However,
So-
if we did not get a climb in voltage, that means the DC to DC converter is not working for some reason, or the cabling between the DC to DC converter and the 12-volt battery, it could have issues. So what we need to do is check the output of the DC to DC converter. Again, this is where you're going to have to go to your service manual for the vehicle that you're working on and find out where it is, and also where the input and the output terminals are.
So in normal car terms, we kind of just want to check the output of the charging system. So
that's
we'd
true.
be checking the output of the alternator. Now we're going to check output of the DC to DC.
Correct.
Okay.
So
Sure.
in this particular case, though, we have two things to check. First of all, a DC to DC converter is an electronic component like a PCM or something is, and it means it needs 12 volts to run.
Okay.
You know, so when you turn the ignition on, it's going to get energized, so we need to check those 12 volt inputs. Again, go to your service manual, find out where they are, ignition and ground, and with your voltmeter, you're going to want to check that. The next step is a little bit tricky. The DC to DC converter runs on the high voltage and current that comes from the big battery.
Okay.
And
Oh,
it's
yeah.
either going to be a connection inside the battery pack, like on this one, or there's going to be an orange wire that goes between the battery pack and an external DC to DC converter. In any case, it's going to be a shielded cable, and you're going to need to figure out if there's power on that orange wire to the DC converter. And I'm not hooking my voltmeter to it to find out.
Right, yeah, that sounds dangerous.
What we're going to do instead is use a low current probe or an amp clamp.
No, that's not, is that a normal amp clamp?
Regular everyday amp clamp, except for it's a very sensitive one. And I don't really know what else to tell you on that. Maybe the one you have is sensitive enough, like this one is, to read a shielded cable, which is what these are.
Right.
Some may not be able to do that. So check yours, check with a vendor if you're going to buy one, to make sure that it's going to be sensitive enough to read a shielded cable.
Okay.
Now you take the meter, and since these are not Cat 3, there's no reason for it to be Cat 3 because you don't. Yeah, because it's inductive.
Okay.
Make sure the system is off, and you turned it off.
Yep.
I verified that when I looked at the voltmeter. And then put the amp clamp around the orange cable that feeds the DC to DC converter. Now you could turn the system back on, and we could observe the amp clamp and see if there's current showing up on the amp clamp.
And what would we expect to see
Oh,
on
somewhere between 1.5 to 4 amps or so is average on most of these hybrids. Of course, but at high voltage levels too. So you don't want to touch it. Just go ahead and read it. And if you see that kind of current flowing, then you know you have input to the DC converter.
And this is voltage flowing or amperage flowing into the DC to DC.
To the DC to DC converter,
Okay.
powering it up, so that it in turn can power the car's 12-volt electrical system and the 12-volt battery. So if we see the voltage flowing or the current flowing to the DC to DC converter, and we know that our turn-on terminals, our ignition and ground terminals are okay, then, and the DC to DC converter has no output, well, then we know we need to service the DC to DC converter. So you can see it's kind of a three-step process. First of all, we're going to check battery SOC either up front or here. Then we're going to open up the door, and we're going to see it drop, showing our hookup is good. Then we're going to start the vehicle up and watch the current climb or not. And then if it doesn't, we're going to move to the DC to DC converters terminals to find out if it's okay. But in most situations, when you do this test, you're going to find that the vehicle's battery is just bad because it's old and grumpy and need replacing. But you got to do these things, because what if you sell the customer a battery, hook it all back up, and then the next day they're calling you because they have to jump the vehicle again because you didn't check the charging system. So go through the process, get it done right, and you won't have any problems. And the neat thing about it is you really didn't need any specialized test equipment either.
Right, these are just normal tools, and to me it sounds like a normal charging system test, except instead of an alternator we have a DC to DC converter. That really seems like the only difference.
Pretty much it.
So,
all right, let's go back up to the front.
All right, let's see if we got any more questions or comments from anybody here. We don't, so okay. Well, I'd like to take a moment here to thank Holiday Ford in Fond du Lac, Wisconsin here. They let us use their hybrid for our demonstration today, so we really appreciate that, guys. And anything else from you, Jim?
Yeah, check my YouTube channel too, at the Wrenchin' Up with Jim Bates show, because oftentimes there are some hybrid things on there that we go over, and you may get some more information on that, either on the tools or on some procedures themselves. And in a few weeks, we even have the Dorman people coming on, and they're going to show us how they remanufacture the high voltage batteries that they offer, in case you get to sell one of those, or you have a customer that need ones. How was your nap?
It was very nice, very nice. Hey, I was walking across the back of the vehicle and I found a couple things. What's this?
All right, well, this is, of course, like most vehicles that have those tamper-proof fuel doors, you know.
No gas cap on it.
So you can, there's no gas cap. So you poke that in there, and then if you have to put gas in it on the road, that's what that's for. This is what comes with the vehicle to plug it in. This is a plug-in hybrid.
Very cool.
So you plug it in, and it uses 110 in this particular case, and in about, I don't know, 12 hours or something, you know, it's got enough charge in there to where you can drive around for X number of miles, depending on the vehicle, before the engine even has to run. It's kind of cool.
That is cool.
Yeah, and that becomes a hybrid again. Be sure to look at my YouTube channel. I did an interview with the folks from Vitronics, or I don't know, however you say that. Anyway, they make one of these things that has a plug on it that you pull it off, and it's the 220. So either 220 or 110. That way, if you are an owner of a vehicle like this and you're out and about, you can find a 220 outlet and charge it up in 4 hours, instead of overnight, which is very, very cool.
So are they coming out with an aqua one? An aqua car?
An aqua car.
Yeah, so when I drive over to Russia, and I got to plug in the 220, I can put the adapter in here and plug her in.
I don't know. An aqua car.
An aqua car.
You're
Yeah.
just
Very
better
good.
off bringing a gas can, I think.
I guess they have, James Bond had an aqua car.
He did. He did.
Yeah.
Actually,
Maybe something like that.
that's
you
very
go.
cool.
Right.
Okay, wonderful stuff. You guys did a very good job.
Oh,
Very
thank
nice.
you.
I learned a lot.
Did you? Good.
Yes, I did.
Good.
And anything else you guys want to add?
Yeah, November 5th will be our next class out. We're going to be talking about fuel injectors. We have a car with some faults on it. It's running poorly, and talk about fuel
You showed
injectors.
that. Yeah, that's very cool. Fuel injectors. Okay, anything else?
No, that's it.
I want
That's
to
just
say
simple
thank
it
you,
is.
Jim, for coming.
Oh,
We
you're
do
welcome.
appreciate
Glad to be
that.
here.
We'll have you back again.
All right.
If
Thank
we can
you, Jim.
afford
All
you,
right,
I don't
thanks,
know. You're a pretty expensive guy. All right. Thanks a lot for being there. Without you being there, we would not be here. We'll see you again next time in the Wells Tech Garage.
See you then.
Bye.